Well, okay. Haven't we been learning how the work, force times distance, I can actually just take the force and do force times dx and do the antiderivative with respect to dx. Or I could want the change of momentum. I can just do, which is, should be force times time is change of momentum. Well, if I have a function that's a force, I can just do f dot dt. That's how they work. Those silly calculus formulas are not silly at all. Isaac Newton really meant, okay, the masses depend on this x, function of x. It's rho 0 times x. That's my density function. I'm just going to write it in there. Times dx. That's every little x, every little piece. Okay, and it means I have multiplied this. So this is the density as a function of, so rho 0 must actually be like mass, kilograms per meter, with x in meters, right? So that this is a density function. But to get some location, I'm just going to multiply by mass times distance and then divide by the total mass. Which would just be, is it dx? No, I need one more x. That's right. Because I need to multiply my little masses. This in itself is the density function. I need to multiply it by a mass and then add them all up. Whereas on the bottom, to get the total, I just integrate the whole function. We can drop our y because we don't have any x's. We just add up every little piece from 0 to a in the denominator to get the total mass. And to get the location of the center of mass, we multiply each x coordinate by the density that's found there. Okay. That is a little complicated. And it's new. Hold on. Yeah, I won't move my math. You should have that picture though. Okay. So my top, I integrate the density function rho 0 times x again, so squared dx. And it's just a constant. Oh, and I have to integrate from 0 to a. If you haven't really stressed integrals a lot in calculus class, you do the antiderivative and you evaluate final minus initial. Okay, so that's rho 0, and then we'll have a cubed over 3 minus 0 cubed over 3. See how I got that? Went from x squared to x cubed, and I substituted right away. Ooh, geez, does anybody need me to slow down and show the function in between in the substitution? Okay. If I was unsure of myself, this becomes, we did antiderivative, so it becomes the third power, and then I evaluate it. Final at the top minus initial at the bottom. Okay, we just do the integral. And then I need the bottom. Okay. So that's just a cubed, that's rho 0, excuse me, times a cubed over 3. Because of zeros, I don't need zeros. Okay, and then total mass. Very important. I just integrate my function with respect to x. 0 to a. X squared over 2. And then I divide them. Okay, so we had this linear wedge. It was increasing linearly. If I take this, divide it by that, whoop, should have an a there. It's 1/3 divided by 1/2. So it's just 2/3 A. Everything else should cancel out. Okay, and that should kind of make sense. If I have like this wedge of cheese that's getting thicker and thicker constantly as I go from the pointy end to the flat end, the actual center of mass is 2/3 or most of the way towards the flat end. Okay. Any questions? Okay. And that was only one direction. So then this is your challenge for, let's see how much time. So 6 minutes. Fantastic. There's one problem left. That was 70. We'll zoom out a bit. There's 72. Good. Don't worry. In-person people. I did say there was 2 free responses from 2013 due Wednesday. If you're working hard tomorrow and doing good, those can be postponed if we're interested in lab. On the other hand, if lab is like done in 20 minutes tomorrow, then maybe those should be due Wednesday. They're problems from online. Okay. Anybody still needs 70? Okay. I will show you how to set up 72. Intentionally not finish it. Okay, but if you had those guys down, so 72, you're cutting out a cube. Oh, and it's constant density, isn't it? Yeah, it is. A cube. So this is not a calculus problem at all, but geometry. Okay, but it might take calculus skills to do it. So it's a symmetric thing at the origin, right? So every dimension is going to be the same. You could write that logic out. You might write a sentence or so. I'm going to have to, so let's call that rho. Okay. To get the center of mass on the x-axis, I need the total mass, density, times x, and then integrate. Oh, yes. And I forgot to show this before. So, okay, I have this object along my x-axis, and I'm actually slicing it. Have you done this in calculus class? I'm doing like tiny little slivers of it, and each sliver has a width dx. Okay, you've done that. You're slicing a graph or something up, dx. But in physics, we say it also has a tiny mass, because physics objects have mass. And we call that little dm. Just like this is an infinitesimal unit of length on the x-axis, this is an infinitesimal piece of mass. But it's just the same density that the object has times the infinitesimal length. Okay. We might make a one-dimensional object or something with a linear mass density, but we won't worry about that now. Okay. So what I have is the little infinitesimal masses added up along the x-axis. And then I have the little infinitesimal masses just added up. So I add up all the infinitesimal masses, the little dm's, which is just rho dx along this line, and then I throw an x in there. Okay. Except in this case, I can't evaluate from 0 to a, right? Or the ABC. Oh, it's 0 to b. Great. That's so good. I have to integrate from a to b. So on the top, I would get x squared, I would get rho x squared, and the rows will cancel, remember, just like the last problem. So I'm going to get a rho times b squared minus a squared over 2. Okay. And I have to do them all at once. You saw it, let's see, you glimpsed the answer. So I have to do 3 dimensions. Right. Oh, yeah, yeah, yeah. So it's b minus a up there. That's just the top. And then you'll have the bottom. So evaluate that antiderivative. And it's just a constant row. And then so you do it, and you get in all 3 dimensions. You're going to end up, like, to add terms together. Oh, no. Oh, that's right. It's a little bit of algebra to do. Like, you're going to have to make, the reason why it comes out with x to the 4th power and y to the 4th power, you're going to have to make common denominators at some point to add the terms together to get the x center of mass. And then it's symmetric, so y and z center of mass should be the same. So that's your challenge. Show some reasonable algebra. I was impressed and pleased because the homework that started looked long. So there's a lot of algebra for 36, so I gave you shortcuts. And for this one, luckily you only have to do 1 dimension successfully and then recognize the others are the same. Any other questions? Okay. We got less than 10 minutes to go. If questions come up, I'll happily answer them. Good. Turn that in first thing tomorrow. Come in ready to record the rest of your data. Make sure you're changing something so you actually get a slope of not 0.